Okay, solving systems using the elimination method, and I'm going to do each case. So this is the one solution example, the most common case, and when we get to the applications, this will be the only case we use. Again, I'm using the elimination method because it emulates the matrix method that we're going to learn in the next section. Alright, so remember, the elimination method wants us to eliminate one of our variables. We want our variables to be, pick one of our variables to be opposites of the same number. And so what I'm doing, there's two ways to go. Alright, so these are kind of where students can solve these two different ways. I usually go with the easiest method if there's an easiest method. And so the first thing I look at are either of my, so I've got two variables, right? I've got the x variables and the y variables. Are either of my variables already opposites, meaning is one of them a positive and one of them is negative? And the y values are, right? I've got a positive 5y and a negative 4y. And so that's my rule of thumb is. If they're not, then I kind of just pick whichever one I want to pick. But that's the first thing I look for. It's one of them, because I tend to lose negatives. So I pick one where I've already got a negative and a positive, so I don't have to worry about any negatives. All right, so I'm going to eliminate the y. All right, which means I want the y, I need to make the y's opposites, they already are, but of the same value. Alright, they're already opposites, but they're not the same value. If I add them up, they won't be eliminated, right? If I took 5 minus 4, I'd still be left with a 1y. I don't want to be left with a 1y, I want to be left with a 0y. And so, in this case, since 5 is a prime number, the smallest number that I can get is 20, right? Multiply them by each other. I can get a 20 and a negative 20. And so I'm going to make them plus and minus 20y. Alright, and then I can add them up and they'll be eliminated. Now, I can't just randomly switch them to 20s, right? In order to do that, I have to multiply by the number, and when I multiply an equation by a number, I have to multiply the entire thing so I don't change the problem. As long as I multiply everything in the equation by the exact same number, I've not changed the equation. And so that's what I have to do. So in the first equation, I want to make the positive 5, 20. And so I'm going to multiply it by, not 2, I'm going to multiply it by 4, right? If I take 5 times 4, it'll give me out of 20. But I put parentheses because I have to distribute that 4. I have to multiply everything in the equation by 4 so I don't change the problem. I'm going to do the same thing in the second equation. I want to make the negative 4 negative 20. Well, I'm going to multiply that by 5, right? I multiply by the opposite number. And so I'm going to get a new system that's the same as the old system, but is going to allow me to then add them up and eliminate the variable I'm asking to be eliminated, the y in this case. And so in the first equation, remember, I've got to make sure I distribute that 4, so everything gets multiplied by 4, so I take the 2x times 4, so I get an 8x. I get my 20y, which was the goal, and then I get my negative 9 times 4, which is negative 36. Same equation, same solution set, so this would be, again, that line would be exactly the same if I graphed it as the previous line. Do the same thing for the second one, but this time I'm going to multiply by a 5, so I'm going to get 3 times 5, which is 15. I get my negative 20y, and 5 times negative 2 is going to come out negative 10. Right, so again, all I did was manipulate the equations correctly, using correct algebra, to get my y values to be opposites of the same number. And now I can add them up and do the elimination part. And so if I take my two equations now, and I add them up, adding like terms, so I add the x terms, the y terms, and the constant terms together. That's why we line them up that way. And so when I add my x terms up, I get 23x. The y's zero out. Alright, so they're gone. They zero away. And then negative 46 I'm left. And there's my simple equation. And so 23x equals negative 46, which is, again, easy to solve. I just divide by my 23 on both sides. And so x comes out negative 2, which, again, is not the entire, so this is, like I said, this was going to be a one solution case. That's only half the solution. In order to find the other value of my pair, I have to go back and plug it into one of these two original equations. You could pick either one. I'm going to pick the first one, so I'm going to plug it in 2x plus 5y equals negative 9. You could have picked the other equation and plug it in there and get your y value. You should get the same thing. So if you pick the other equation, you could check against mine, and you should get the exact same y value. Again, that's what makes them equivalent, right? They have to come out the same. So 2 times negative 2 plus 5y equals negative 9. Alright, and so when I solve that, I get y equals negative 1. And so there's my one solution to the system is the point. X is negative 2, y is negative 1. If you graphed them, and you can do this on your own if you want to, that is where the two lines should intersect. But to graph them, you have to do a little bit of work, right? I'd have to solve for the y to graph these. And if I solve for the y and I graph them, and then I have to find the point of intersection. So again, you could solve it and check your answer graphically. I'm not. This is the correct answer, negative 2, negative 1. So there's the one solution case. Right? And then I'm going to do the next special cases in the next videos. Maybe if I